Hi class, let's take a look at example 5. Now in example 5 what we're given is to solve equations, and here you have all the main rules, and the basic idea here is the following. So you're going to have an equation, and in order to solve it you're going to do the same operation to the left or to the right. So if you're subtracting values, you're going to be subtracting the same value. If you're adding values, you're going to be adding the same value. And same idea for any division or multiplication. So for example, let's take a look at the first problem. And let me approach this one by just doing addition to the equation. So in order to completely isolate it, x has to be by itself. So what I'm going to do here is I'm just going to add the values of 2/5. So plus 2/5 and plus 2/5. And at this point, our equation has been technically isolated, but you now have 1/10 plus the values of 2/5. And then at this point, we can simply get an LCD. Your LCD is going to be 10. So multiply times 2 and times 2. And this is going to give us an equation that reads 1/10 plus 4/10, or 5/10, or 5 times 1 and 5 times 2, and we can cancel the common factor of the 5s. So our final solution, it's going to be 1/2 for this one. And once again, the main idea within the equations or solving equations is that you're performing the same operation to both sides. For this one, it was just sufficient to add the 2/5 and then obtain an LCD on the right hand side. Now let's take a look at problem 2, and I'm going to do problem 2 slightly different. So what I'm going to do is I'm just going to make all the values into a fraction. So h, it'll be divided by 1. And then notice how on the previous problem, we ended up getting an LCD at some point. So this step or this procedure may be faster if you find the LCD first. In this case, you're looking at 1, 4, and 5. So your LCD is going to be 20, and then multiplied times 20 both sides of the equation. So let me rewrite the equation. So this is h plus the values of 3/4. This is equal to 2/5. And to each part of the equation, we're going to be multiplying the 20. Keep in mind that that's a 1, so 20. And what this is going to do is, in one step, it's going to cancel all of our fractions. So let me rewrite what doesn't cancel. So you're going to have the h plus the 3. This is equal to 2. And let me write in green the values that result from the divisions. So 20 divided by 1 is equal to 20. And then 20 divided by 4 is equal to 5. And 20 divided by 5 is equal to 4. So our resulting equation after the cancellation of all fractions, it's actually going to be, 20h plus 15. This is equal to 8. And let me wait a minute. So what we're doing here is by multiplying by the LCD, all your fractions cancel. But remember that every element of the equation needs to be multiplied by the LCD. And then at this point, let me subtract the 15. And let me move the work up here. So we're looking at the values of 20h. And 8 minus 15 is going to equal to -7. And then we'll do a division of the 20s, so that our final answer, in this case, our value of h is equal to -7/20. That's it for problem 2. Let's move on to problem 3. And good news on problem 3, it'll just take one step. So because the q it's being divided by -4, multiplied by -4, but that means that on the right hand side you're also multiplying by -4. So we're looking now at just q on the left hand side, and then on the right hand side you have -40 times -4, which is equal to 160 positive. So your q value, it's 160. So this one took one step. Very similar process to the previous one, but since you don't have additions, in one step the multiplication cancels the fraction, giving us the value of 160. Let's take a look at problem 4. Now in problem 4, what I'm going to do is I'm just going to subtract the 3/4. So subtract the 3/4, subtract the 3/4, and we're looking at -2/5 minus 3/4 is equal to x. Our LCD is equal to 20, so multiply times 4 and times 4 times 5 and times 5, and then let me rewrite it as -8 over 20 minus 15 over 20 is equal to x. And this step was just to verify that we do have the same denominator. At this point, let me add them, and you're gonna end up with -23/20 is equal to x. And let me just flip it so that we have it in the proper format. So our final solution, x is equal to -23/20. That's it for problem 4. As you notice, it may be the same amount of work whether you add the fractions or multiply by the LCD. It seems like a lot of work as you're multiplying by the LCD, but on the long run for messy problems, it'll be faster because you're not dealing with additional fractions. Let's take a look at the last one. And on the last one, let me multiply by the LCD just so that you guys have another example. As I mentioned before, they do tend to get very messy, and in that case the best is just to multiply by the LCD. So technically your LCD is equal to 24, so we're going to multiply both sides by 24 and by 24. So let me rewrite it, and we're looking at -2/3 is equal to y plus the values of 3/8, and every one of these gets multiplied by 24. And let me write in green the divisions that are going to cancel your fractions. This is a 4. Technically over 1, so that's going to be an integer. So for the next step, let me write what doesn't cancel. So in this case, we have a -2. This is equal to the y plus the values of 3. And let me write in green what cancels and reduces to, in this case, 24 divided by 3 is equal to 8. Well, this will be times 24. And 24 divided by 8 is equal to 3. So we're looking at -16 is equal to 24y plus 9, which at this point we could just subtract the 9's. And let me rewrite it. We're looking at -25 is equal to 24y. So we could just divide by 24, divide by 24, and end up with -25 over 24 is equal to y. And let me flip it. So we're looking at the values of y is equal to negative 25 over the values of 24. That happens to be our final answer. I'm going to leave them as an improper fraction as well because, well, none of the values are given as mixed numbers. That's it for these set of problems. I'll put the rest, which are slightly different, in a different video.